In this video, we are going to cover exercises related to material covered in the chapter 19. As usual, you can pause the video after you see the question, answer the question on your own, and then see my answer. First question: which of the following molecular orbital diagrams represents cyclopropene cation, C3H2+? And formula of cyclopropene cation is shown below. Obviously, cyclopropene cation has 3 carbons in a ring, and we use this mnemonic to draw relative energy levels of cyclopropene cation. Mnemonic is that we draw energy levels in such a way that they are at the corners of a polygon that has same number of atoms as those in the ring. So 3 atoms in a ring, we draw a triangle with 1 corner pointing down. Since correct drawing of energy levels is that 1 corner has to point down, C and D cannot be correct answers, because in this case side of triangle points down. So only A and B have triangles with corners pointing down. C and D, of course, side. So, and among the two, A has free electron pair or 2 electrons in the lowest energy orbital, following Aufbau principle and Pauli exclusion principle. So we have 2 electrons from a pi bond. They are in lowest energy orbital. Higher energy or 2 higher energy orbitals, anti-bonding orbitals, are empty. B would be an excited state. That's not obviously correct structure. We are looking for ground state. So correct answer is A. Question number 2. Cyclopropene cation shown above it is aromatic because bonding orbitals are filled, anti-bonding orbitals are empty. So that's aromatic compound. Anti-aromatic would have unpaired electrons, and non-aromatic and alkene are the same thing, and that means that you would have an ordinary alkene without electron delocalization. So in this case, correct answer is A. Next question: what is the major product of the following reaction? It's typical chlorination reaction, so benzene reacts with chlorine in the presence of iron trichloride. The only possible trick here is to recognize that iron trichloride is Lewis acid, and typically we use aluminum trichloride, but any Lewis acid works. Zinc chloride would work, gallium chloride, so any Lewis acid will work. And so product is typical chlorination of benzene ring, so chlorobenzene. A. Next question: which of the following statements about Friedel-Crafts alkylation is or are correct? An alkene is a suitable starting material. Any starting material that can give carbocation is suitable starting material. Obviously, protonation of alkene is common reaction to form corresponding carbocation, protonation by strong acid like sulfuric, or even not as strong like phosphoric or perchloric, so that's correct. 2. It involves the use of stoichiometric amount of Lewis acid. That's not correct. Friedel-Crafts acylation requires a stoichiometric amount, but not alkylation, so that's not correct. And 3. It often involves in rearrangements. That's correct, because if carbocation is an intermediate, rearrangements are common. That means that 1 and 3 are correct, and that corresponds to answer B. Next question: which of the following compounds would you expect to be aromatic? Free electron pairs are not shown. So you need to know that positive charge means empty orbital. There are no free electron pairs. Negative charge on carbon means free electron pair. And for heteroatoms such as oxygen, nitrogen, sulfur, you should know how many free electron pairs are there. So A, there are no free electron pairs on positively charged carbon. That means we have only 4 pi electrons, 2 from each double bond. And so 4n plus 2 equals 4, so n is not a whole number, so A cannot be aromatic. B, a free electron pair on nitrogen is not delocalized, because nitrogen already forms double bond with carbon, and free electron pair is in hybrid sp2 orbital. And electrons in hybrid orbitals cannot be delocalized. Electron has to be in unhybridized p orbital to be delocalized. In this case, unhybridized p orbital has already been used up to form a carbon-nitrogen double bond, and so electron pair cannot be in that orbital, therefore it's not delocalized. So we have only, again, 4 pi electrons from 2 double bonds, and again, same as before, compound is not aromatic. C. This free electron pair is in unhybridized p orbital and is delocalized. And now we have 6 pi electrons, and that means that solves this formula for n equals 1. And since n is whole number, then this is aromatic compound. D is not aromatic because we have, again, 4 delocalized electrons, if this compound were to be delocalized, because negative charge on carbon means free electron pair. And 2 electrons from double bond, 4 electrons. So, correct answer is C. Next question, which one of the following statements correctly describes effects of a substituent on an electrophilic aromatic substitution? Nitrile group or cyano group, deactivating, that's correct. That's the activating group. Orthopara directing, that's not correct. It's meta directing. Next, carboxylic group, it's deactivating, not activating. So that's not correct. Orthopara directing, since it's deactivating, it's meta directing. Again, not correct. Nitro group, deactivating, that's correct. Meta directing, that's correct. So C has both statements correct. Looks good so far. Chlorine, activating, no, actually it's deactivating. So that's not correct. Meta directing, that's not correct. So correct answer is C. Question number 7. Reaction of benzene with a mixture of concentrated nitric and sulfuric acids followed by treatment with zinc and hydrochloric acid and basic workup gives which of the following compounds? So in this paragraph, basically you have a number of reactions, and best is to write them down. Use pen and paper, write them down and figure out what is the product, and then match it with one of the 4 possible choices. We start with benzene and nitration of benzene. A reaction with mixture of concentrated nitric and sulfuric acids, that gives nitrobenzene. Then treatment with zinc and hydrochloric acid, that's Clemmensen reduction, and that reduces nitro group to amino group, but since amino group is basic, it reacts with hydrochloric acid to give hydrochloride, so anilinium hydrochloride. And then basic workup, that releases aniline from its salt. So product is aniline, and correct answer is A. And now some free response questions. What is the trivial name of the following compound? So this is a compound that you simply need to recognize. And trivial name is xylene. 2 dimethyl benzenes are named as xylenes. We have 3 possible xylenes, ortho, meta, para. In this case, 2 methyl groups are meta relative to each other. So this is meta-xylene. And the final question, what is the product of this reaction? This is obviously Friedel-Crafts acylation. So reaction of acyl chloride in the presence of aluminum trichloride followed by aqueous workup. So in this case, product is propiophenol. So this completes chapter 19 exercises.